Okay, here are perfect problem 2 solutions for Math 112. You're given this mess of a logarithmic equation. This is actually a pretty challenging problem to solve. It has to solve it. So what can you change all the x's into to make this side of the equation the same as this side of the equation? Okay, so it's hard enough that I figured it would be worth pointing out a couple hints. So the first hint I said is kind of deal with this inner part here. Use log rules 1 and 3. When I say that, I'm referring to these guys. I think in class I introduced them as 1, 2, and 3. Not that that's anything universal, just terminology I made up. To simplify this, okay, first comment, you cannot do anything here with this exponent. It might look like it fits log rule 3. You might think you can take this 2 and bring it down in front, but you can't because this entire log base 2 of 2x is being squared. If it were the log base 2 of, and then the 2x were being squared, then you could use the log rule. But that's not the case here because this squared is outside this outside parenthesis. This doesn't apply. However, we can use some log rules here. We can say that log base 2 of x plus log base 2 of 4x using this first log rule is equal to the log base 2 of whatever x times 4x is. So in this case, 4x squared. This x times this 4x. And you're like, oh yeah, okay, now log rule 3, take this 2 and bring it down in front. Not quite. You can only use log rule 3 if the thing you are taking the log of is being raised up to an exponent. That's not the case here. This 4 is not being squared, only this x is being squared. So in order to make it fit log rule 3, what we'll have to do is recognize that 4x squared is the same as 2x squared. So squaring this entire thing gives me this. And the advantage of writing it in this form is now it finally fits log rule 3. So I can say this is equal to, take this 2 and bring it down in front, 2 times log base 2 of 2x. Got a few options on what you could do here. You have options on what you do here. I'll leave it at that. I think it's easier to not go any further, so I'm going to stop here. You could break this up into different logs. You could apply this rule in reverse and simplify. But rather than do that, I'm just going to solve this equation. I'm going to say, all right, I got the log base 2 of 2x, and that entire thing is being squared. It's my first term. And then these next two terms give me 2 of these log base 2 of 2x things. And then that is equal to log base 3 of 9 to the 4th power. That's just a number. There's no x's floating around in here. In fact, if you wanted to, you could apply this third log rule to bring this 4 down in front and say it's 4 times the log base 3 of 9. But because the log base 3 of 9 is just 2, it's 4 times 2. In other words, it's 8. So really what I have in my equation here is the log base 2 of 2x. That entire thing is being squared. And then to that, I'm adding 2 of these log base 2 of 2x things. And that's equal to 8. And this is where you can do a substitution to solve. That's what I was getting at this second hint here. This thing in the parentheses here, I also have one of them over here, this log base 2 of 2x. So what I'm going to do is I'm going to pick whatever letter you want. I don't know, y. Because why not? Let y equal log base 2 of 2x. And if you do that, then what you can do is rewrite this equation. Really what you have is y being squared, because log base 2 of 2x is y. Then over here you have 2 of these y's. And y squared plus 2y equals 8. That's an equation that looks a little bit less intimidating than this mess of an equation up here. To solve this, since you have a y squared term and a y term, maybe set it equal to 0 and factor. Y squared plus 2y minus 8 equals 0. So y plus 4 times y minus 2 equals 0. And therefore either y plus 4 equals 0 or y minus 2 equals 0. So either y is equal to negative 4 or y is equal to 2. Done. Not quite. Because remember, in this original equation, our variable is the letter x, not the letter y. Y is just something I created. It's something I made up right here. So really, I've solved for y, but y has no meaning. It's just something I created. So what I'm going to do is say, all right, if y equals negative 4, and y is log base 2 of 2x, then really what I'm trying to figure out is when does log base 2 of 2x equal negative 4? And similarly, when does log base 2 of 2x equal 2 for this one? Well, let's see, if you're solving these two equations, a couple options on how you do it. I think what I would do is write it in exponential form. So I would say, okay, this is the same as saying 2 to the negative 4th power is equal to 2x. And this is the same as saying 2 for this little base squared is equal to 2x. So 2 to the negative 4th power is 1 over 2 to the 4th power, which is 1/16. And then 2 squared is 4. So if I solve for x over here, I'll divide by 2 and get that x is equal to 1 over 32. And over here, if I solve for x, I'll divide both sides by 2 and get that x is equal to 2. These right here end up being the solutions to the original equation. And you can check those if you're feeling especially ambitious. You can change all the x's into 2's and check. It'll all work out right. You can also change all the x's into 1/32, and this will work out right as well. But I'm fairly confident on what I did, so I'm not going to bother checking my answers. I'm going to let this, not the prettiest work, but I guess I'll let it suffice. Call this good and end the video here.